So today's talk is a lot about defining the problem. So before I get started, can one of you tell me what is a good performing application for you? Can you just name a characteristic, any one of you? How would you name an application? How would you call an application good performing? Any one characteristic? Availability, response time. Somebody, you said amount of memory that it uses. Something which is more cosmetic, like, usability. Even a little more specific cosmetics. Nice looking button, but can't hit it. My finger is too fat for this button. Yeah. Or, things fly around way too much. I don't know what happened. Or my screen just hung before the next one came. So many things are all performance. Right? Sometimes what happens to us engineers is that we tend to look at performance with a great pragmatic sense, which is like, how much of interactivity am I getting in X amount of time? What is my scrolling performance? You always put them into like a tangible smoke test. Our QE friends here will put it into a smoke test and say, yeah, looks cool. But then you give it to a real guy who's running it off a machine. There is something called perceived performance. And 9 out of 10 times what I have realized, I'm rather new to building for mobile. I have to confess. I've started like probably a year and a half ago. I was a regular desktop guy before that. So what I realized is like, to build a great application, you have to build great perceived performance. So the things that give you analytical performance, the performance that you can tick against a spec, will not actually give you great perceived performance. So you have to kind of marry both these concepts together to actually arrive at something which works really fast and something which actually satisfies your need as a fast mobile application. So I will cover performance metrics. Then I have to cover some bit of MX to Spark, because for the Flex guys specifically here, people who have done Flex 3 programming in the past, I'm sure, has anybody done Flex 3 here? Some of us have done Flex 3 here. I have some things specifically for you guys, considering the fact that you are moving to the next framework stack, and there are things that you need to keep in mind. itemRenderers, this is not a Flex concept. It's a concept that is universal across all platforms that you build, but I'll throw some specific focus on itemRenderers on Flex. But whatever I tell over here is extrapolatable to any sort of technology that you're applying this to. And finally, yes, what you need, typically how you build a item renderer, a terrible item renderer, and a good item renderer. So I'll actually show you examples of that. Now, I didn't have to work very hard to build a terrible item renderer. It just gets built. So, we will see as to how each one of them kind of pans out. So the metrics are as follows. Execution time, startup and validation time, frame rate, memory, Swift size. Most of this was covered. All of us kind of called this out. But interestingly, this frame rate as a concept became important only pretty recently. Like even JavaScript people started talking, what is the frames per second for an application? Anybody knows what a frame rate really denotes? Yep. How fast the screen is being redrawn. So that would directly mean that more the frames per second. Is that always true? So when the frames are redrawing very quickly, that actually means that you actually have a monster of a phone in your hand. If you have like a low potential phone, a phone which is not eminently capable of taking that many frames, what you typically get is really, really hot phones. Your phone will just warm up because it has a direct impact on your CPU and battery. There is GPU that we will not really cover here, but there's questions I can take them. So frames per second is a very, very critical metric. But if you are running an application that runs at 60 frames per second for 20 minutes, I can promise you, whether it is JavaScript, whether it is ActionScript, whether it is any language that you're using, you are going to drain out your battery. So frames per second is an extremely critical but extremely tricky metric. So our aim should be to build great frames per second, great frame rate for things that we are doing on the application. For example, if you are scrolling something, tapping something, throwing a list, you need great frames per second performance there. But your application is idling. Like if it is just staying without doing anything, we need to think in terms of whether how much frames per second. If your screen is not refreshing, for example, you have like a login screen, do you want to run it in 60 frames per second? You don't really have to. So that's a place where we spend some time today in terms of understanding how frames per second varies and where is it important to have a higher frame rate and where is it okay to have a rather low frame rate, because you will not see a lot of difference. Then comes the memory. I don't have to say anything about it. Everybody knows you have to build applications that don't leak memory. Swift size. Debatable in the world of mobile applications. Once you have downloaded your application, you have spent some money using your Edge network or your 3G network, you're done. You're not really worried about space, but you would be if it is like a 50 MB application. Correct. Like somebody has an SD card. Not everybody has an SD card of like 2 GB or 4 GB orders. People are still running rather smallish sized. Yes. So size of your application is critical. Not so critical if you are forward looking, if you're going to buy phones every 1 year, just the way Apple releases phones, and people keep updating. My friend Hemant is not here. He buys a phone the moment Apple releases one. So if you are sort of a quickly hopping person, then that's not such a concern. And finally, the perceived performance. So perceived performance we will see as we actually do some of these optimizations. So this is a very, very important slide. I would like to kind of reflect on this slide and kind of look at it. There are two separate pie charts over here. One is effects, scrolling, transitions is one bucket. Startup, navigation, and data processing is another bucket. So the first one is actually interaction. Touch, scrolling. When you actually move one view to the other, how the transition happens. So there, the way your runtime executes your code is sort of different from the way your code is executed when you're actually doing startup or just plain navigation, no effects. You're clicking something, it's actually popping a view and putting a new view, or simple things like populating a table or showing a list. So we have to clearly understand that these two buckets actually are treated very differently by the runtime. The first one, if you see, effects, scrolling, and transition, the render consumes 67%. What is rendering? Rendering is what we just now mentioned. How is the screen rendering? How quickly is your your screen refreshing? And in the meantime, your action script takes only about 23% of the execution. While on the other side, it is mostly the chunk of time or the chunk of resources is actually taken by ActionScript or the comparable language. I mean, honestly speaking, I've been doing a lot of jQuery, Sencha, HTML5 experiments at the moment. So I can very easily extrapolate some of these inferences to that because the rendering, the way a screen renders or way an effects or transition pans out cannot be different across platforms. They might have different implementations, but they all mean the same at the end of the day. So understanding this is very, very critical. So if you have effects, scrolling, and transitions, please understand that we need to optimize rendering. Because render consumes so much. The moment you actually reduce your rendering time, keep reducing your rendering time, you will get much more seamless visual experience. When you're scrolling something, that thing just flies, or the kinetics are showing up. At the same time, if you are doing like querying an Ajax backend or a database or a SQLite database and populating a list, then there is a lot of data crunching that is happening, which will freeze your UI. There's asynchronous and synchronous way of dealing with data. So your screen freeze is a big challenge in mobile applications because sometimes even those circling loading indicators, if you have seen, they will also tend to freeze if something is modifying your UI. How many of us have seen that? Whichever platform. May you be on HTML, you be on native. If you are actually working on a single threaded model, if your UI thread is not allowed to be kept separate, if there is synchronous data or if there is heavy data crunching happening, your UI freezes. And that is the first instance of your perceived performance taking a hit. You're doing everything right. There's nothing that you're doing wrongly, but hey, your application is not exactly performing. You're not doing anything. You just click the button and you're waiting. But you still want the application to have that fluidity. Somebody mentioned that fluid word. The fluidity is very, very key. So this distribution is something which we need to keep in mind. So this percentages might vary across runtimes. Now, some other runtime would have different percentages, but this pie cannot change. The pie distribution, the ratio in which this pie has been set up, will not change. So don't go by the absolutes, like, oh, 67, I need to get it to 65. That's not how it works. So it's a way of understanding that it is the major chunk, and we need to try and optimize that chunk to be able to get better scrolling and cosmetic touch performance. In the meanwhile, most of your data crunching happens in actions. So if you're running like a brute force 3 for loops, like I, J, and K, running across 200 items, your UI is going to hang. That's sloppy programming. Sometimes I just mention, sloppy programming and sloppy design is technology agnostic. That is the most cross-platform thing in the world. You can screw it up with any language. So you need to think about that at that moment. So let's just now move forward and go to a little more specifics.
How much I can take it as a generic for a mobile app, any mobile
you would no, you would see the distribution, and the thing is, since I don't have statistical evidence, I don't have a smoke suite for multiple platforms. That's not scope for this session, but with due diligence belief that you can apply on me as a person who also works on other technologies. So you can actually take a modest judgment in terms of what it can be. You need to apply that that rule of thumb of watering down that you need to do. You need to do that plus or minus 10 as you would prefer, but you cannot absolute on based on one technology. So, but most of it is actually applicable across. Let us move forward. Some of these are really stupid things, but sometimes we tend to forget really, really stupid things and do much more stupid things. So use the best component for the job. I will come to this in a moment. Cache and queue external content. Let me just ask you, what is caching? Anybody, all of us knows. At a browser's context, what's cache? Got something. If that is not changing, or if there's a belief that it's not going to change, let's use it. Correct. What is queuing? Don't do everything together. Yo, you have multitasking. You can do like several things together, but do you really have to? It's a question that sometimes we need to ask us. Sometimes the platform will open out endless possibilities to you. You can actually like spawn off like 6 different things because there's asynchronous event model, there's threading, there's all sorts of blah. But sometimes using simple things like queue your operations. After doing this, do something else. Believe in sequential operations at times will actually give you performance. Though parallelization will make you feel like a Godzilla, sometimes doing things simply and sequentially will actually give you good performance because your user doesn't give a damn. Oh, awesome, like this guy has really implemented like multiple child processors for querying, he doesn't give a damn. My dad doesn't give a damn. Oh, Flex, okay, cool, does it work? Or HTML, does it work? That's how most of your users are. So sometimes going back to your simple drawing board and you do things the way you do before would really help. Use cache as bitmap on graphics that change infrequently but redraw often. Flex developers, how many of us do this here? 3 people, but there were more Flex developers here. That's a good thing. So that's a good inference here. So cache as bitmap is a double-edged sword. It's actually really nice, but it can also screw you really badly. So if your graphics are changing every X point and period in time, don't cache it. What that means is every time the system has to cache, remove the cache, bring something else, cache it again and show, you're losing at least a good 10 seconds in this whole process. So something which changes infrequently, but it is only going to redraw every single time. Like for example, if it's like just a move transition, like going from left to right or something, cache it because the same pixel data will be used and it will be just repainted. It will not load it again and again. So I don't know what the equivalent of this is in JavaScript at the moment. We are still using a DOM-based approach in JavaScript now. You typically load an image asset and then kind of, or add it onto a canvas and then tween it. So it's not super optimized in that world. So you have to still figure out in terms of how you compress and kind of do it. So doing it on canvas is not as easy as doing it on Flex. But in Flex, luckily and thankfully, we have the cache as bitmap directive. I'll quickly speak about this. This is only important for people who are moving from MX to Spark. So MX was the erstwhile component model for Flex. We had that for like what, 2.5, 3 releases, I think. We had them for 3 releases. Then we decided to move on to the new model, which is called Spark. So MX was this good for all, take it for all sort of framework. You had like rich components, lightweight skins and styles, but you couldn't do much with them. So if there's a particular way it works that way. So what really happened is people started saying, my client is already asking for buttons that look like something else. He wants the combo box to actually look like an Apple's combo box, and so on and so forth. So that's where we decided we need to have a more extensible, customizable way of doing your components. That's where Spark came about. It is rich, toolable, extremely customizable, but remember, it's heavier than MX. Why this is called out is because henceforth, we are going to use Spark. And we are actually telling that we are actually going to work with something which is heavier than the previous component set. Why would we do something like that? Something was super lightweight and then we have moved to something heavier. There are specific reasons as to why something has been done in a particular way because that gives you control in terms of what you can optimize. In MX, what you can optimize is limited. You have to believe us in Adobe. You have to holistically think that Adobe has figured it out for you. But that's not always the case. We are still a team of like, 50, 60, 100 engineers who can't really conquer the whole world in terms of what real good performance or real good UI is. That's why a new customizable framework, modularized lighter weight components with graphics which are set as primitives. Anybody has drawn a rectangle using ActionScript here, ever? Not a lot of fun, is it? Is it a lot of fun? It's not a lot of fun. I don't even understand it. I actually copy-paste it. If somebody asks me how to add I've done ActionScript for what, like 12 years now. I still don't know how to add a circle to stage. I just copy-paste that code. So it's not very interesting, at least not for me. So probably for the graphics guy, it might be different. So MXML graphics, like MXML tags to make your rectangles and triangles and your polygons is actually pretty cool. This is where the real session starts. Okay, cool. I'm tracking well. So in MX, you had something called a container, canvas, VBox, HBox, and things like that. So they were nice, right? You can actually put a border for them. You can actually style them. You can give a background color to them. You can actually have like a gradient running inside them. It was really good. But what really happened is, because it has got so much intelligence, it is not the fastest kid in the world. That's why we came to Spark and said, we'll make a group, we make a data group, we make a scroller, and we'll make a skinnable container. So instead of 1, we split them into 4. Splitting them into 4 can be a pain in the posterior, because you don't know which one to use. But the moment you know which one to use, it's actually cool. So that's exactly what this session tries to cover. So most of the times, most of the people whom I speak to come and tell, hey dude, you had like one HBox, which I could figure. Now you have like a scroller, you have like a data group, then you have a V group. The point is, especially building for the smallish mobile devices, more the abstraction, the better for you. So let's just see what really happens. So the groups are like a generic container with MXML graphics support, and data groups have itemRenderers support with virtualization. You know what virtualization is? Not the virtualization in the cloud. This is virtualization in the sense, if you have like 100 items to show in a list, we'll only make 10 and keep reusing them. And almost all smart frameworks do that, not something which we constructed from history or something. It's a general practice, but this component sort of supports that. And groups are much lighter than containers because they don't have built-in scrolling, because they are chromeless, and clipping is by default off. We are all happy when something clips, right? You drop something out and you don't see that. It's nicely masked. This is really cool. But you know how expensive that is? Because the framework has to go figure out how many pixels is outside, how to draw the mask, how to move the mask, and all sort of things. So groups are generally lightweight. And these are authentic, tested information, because I have a demo to show you guys at the end of this. So I didn't do anything, did I? It is not because of me, sorry. So you had a container in your earlier phase. You can actually see that that's creation, the blue is validation, and the purple thing is render. Just because you have all this borderability, skinnability, scrollability, all those things being available in your container, they take a lot of time to create. Correct, you have to add all those respective parts. Then of course, if you add something, you have to validate. Like the width is set, if the height is set, if the X is set, the Y is set. That takes a good chunk of time. And of course, it's an empty box, so it should not take a lot of time to render, correct? Ultimately, it's just a rectangular area, which has got a lot of internal intelligence. So you typically see a render is rather smallish, and the time is in milliseconds. It's about 1.4 seconds is what your container takes to lay out. But just see the group. It is simple common sense. Because we abstracted out, not all groups need to have a border. Do we need to put a border for all groups? It's not a regular need. Then why program for it? Why attribute for it? Have a lightweight piece which actually renders in like 500 milliseconds. It's like half a second. So that's like almost 1/3, right? You're actually saving performance. It's like about 3 times faster by just using a group instead of a container. So the next time you feel the urge to create a UI which has got a header, a content area, and a footer, you will not use a V group, then an H group, then a V group, then an H group. Just drop a group. So what I mentioned is like 4 components. Instead I'm saying just drop one group. Right? Let's just move forward and see. This is another danger, man. Every application has an image, right? At least you'll have a logo. And every list today Let's look at mobile applications. How many of us have a smartphone here? Most of us do. Correct me if I'm wrong. Aren't 90% of those applications lists or sophisticated lists? If it's not a game. True or no? It'll be like a fat list or a thin list or a single line list or a multi-line list or an RSS feeder list or a tweet deck list or an email boxes. They are all lists. Lists with multiple things in it. Most of the times it'll be like a couple of texts and a couple of images and a button or something like that. Typically that's what your mobile application, it changes in tablets of course. Your tablets have a much larger visual area to work with, so you have much better UI paradigms to work with. But I'm purely speaking mobile devices, like the small 640 by 480 devices that we work with. Sorry, 640 by 320 devices that you work with. So that is why this whole list thingy becomes very important. Please feel free to extrapolate this to your jQuery mobile as well as your Sencha Touch list. Whatever I'm covering over here, the principles are eminently applicable to other micro frameworks, even if you're doing so. Bitmap, here the thing about Flex is there are certain really nice things that we do which the HTML world does not do yet. You still work with an IMG tag or like a div with a canvas in it where you actually draw pixel data. That's the only two ways you can do images at the moment in your HTML stack. But here we have a class that we built called bitmap image, which is like a ground raw image which allows remote loading, scaling and caching. That's about it. So you can load a URL, you can cache whatever you have loaded and you can scale it. At the same time, there's a Spark image, which is a skinnable component to start with. You can actually put a skin to it. You can actually show progress. You can check if the image is loaded. You can show like 30%, 40%, that thing. You can actually show a broken icon, and you can even have a chrome around it. Like, for example, like a border or like a beveled border and things and so on and so forth. The thing is, the Spark image is generally used for showing something like a digital camera photograph. If you want to just show a single photograph rendering on your screen, that's when you use. But what commonly happens is people tend to take the Spark image and use them in a list. So a list can contain anything between 20 to 100 items. So 100 Spark images sitting inside your list will be something like that. Of course, there are not a lot of properties. So your creation is pretty simple because it eventually is just an image holder. But since all the progress, broken icon, chromability, skinnability, that causes the validation to shoot up so much that it kills it for you. This slide should actually tell you that if you are ever building a Spark list, mobile list, avoid using a Spark image as much as you can. You can actually do without it. Please, if you see an item renderer with an Spark sitting inside it, stop now. You're already in trouble. If you have gone beyond 10 items, your list will start choking. It will be the most disgusting list, and then we'll all get very worked up and we'll say this whole technology sucks and so on and so forth. We'll start blaming auxiliary things and not exactly us. So that is the reason why I want to tell you. There is MX image, it's obsolete. We don't use them in mobile, but it's still better because it doesn't have all this neo magic that I mentioned. Spark image, mind you, is very useful. It is to show an image, not to show a thumbnail or an icon. If you want to show a right arrow or if you want to show like a collapse button, please do not use Spark image. You don't need that. It's like almost taking a space shuttle to go to Malleshwaram. Don't do that. So there's a bitmap image, which is like your auto rickshaw. Doesn't do much, but it's very, very performant and fast. So things that change rapidly, things that are inside a list which need to scroll, fly, ease out, use a bitmap image. See that? See, it's like for 1,000 instances, it is like 1.5 seconds. Like, mind you, all the charts are against 1,000 instances because I can't really show you any chart without at least having a sampling size of as big as 1,000. So, and you might think that 1.5 seconds is nothing. How many of us thought that? Hey, some of us should have thought that. I thought that myself. 1.5 seconds is nothing. Like, take a breath, it's like 1.5 seconds. But when you are touch scrolling a list, it is a long time. You will actually feel that 1.5 seconds as a huge, 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 huge lag. That is the funny thing about these applications. Like, so 1.5 seconds, even like, just a little longer than a few moments is actually pretty slow. when you're actually using them. That's why some of these metrics are very, very critical to understand. Moving on. Caching and queuing. Again, we added this new in Flex 4.5 and hence 4.6. You have a content cache class, and caching is by default on, and queue is off by default. So there's a content loader property for your Spark images and the new images. So even when you're using a Spark image, use the content cache class to actually load and cache your image so that it doesn't keep making this request every single time you are changing. And similarly, there is an iContent loader interface that you can go and look up. I'm not going to spend time on that. Use PNGs as much as possible. Control the urge to use BMPs, control the urge to use large JPEGs. If you can use PNGs, use them. And use correct sized PNGs. If you know that you're going to show 16 by 16, please ask your graphic designer. No, treat him for a beer and ask him to make that sized image. Most of the times, dude will give you a 256 by 256 and say, scale it down. It'll anyway come down, it's a PNG, there's not much of loss, don't do that. Don't do runtime scaling. If you know that your size is X by Y, make an image that is X by Y. It'll actually save you a whole lot of performance and time in the long run. I have done this myself. I've done this several times. You know, I have one image, I don't have time. I just collapse it down. Or even worse, some people get so paranoid, they actually scale up. Scale up not only will screw your performance, it will actually make your eye bleed. It will look so ridiculous that you can't even look at it. It will actually look like one of those old clip arts that we used to see in, like, you know, bongozongo.com or something like that. So please don't do that. Avoid runtime scaling. Sometimes you might have to. Sometimes you might just have to. For example, I have had a case where I was working with medical imaging. You can't ask a medical imaging guy to give you 250 images for the 250 sizes he supports. So you might have to do runtime scaling, but where you don't have to, don't do it. Yes, sir. We should be good. I actually started about 5 minutes late. 5 minutes late. So you have more choices with Flash. You used to have only a label and text when you were using your older components. Now you have a label, rich text, rich editable text, and stylable text field. So the first three are really nice. They'll do a lot of things for you. Like, you know, like this. Label is single style, can use for mobile. Rich text is multi-style, sorry. Rich text is multi-style. That means you can show HTML in it, you can show multi-line stuff in it. Editable is naturally the extension of that. You can edit it, like, you know, you can type into it. The text area uses that. And finally, there is something called stylable text field, which is actually our friend when you are actually working with lists. We will see how. So stylable text field is the most difficult text component to work with. Because there is no MXML support, you will have to go the very painful ActionScript way of adding them. And I personally hated it when I started. But what happens is, you actually make one class which can be used across all your items. You spend like 2 hours one day and make a class which uses stylable text field. And if you're actually able to reuse it across, your performance gain is about 40%. Like, you'll see the frame rate difference. So the moment you get that sort of a performance gain, that 2 hours that you spend to actually write a stylable text field based item renderer is nothing. Can't use an MXML. If you are dropping an SQL stylable text field, you'll get a compilation error, and that's it. It will not work. So you'll have to use the ActionScript way of doing this. And please, very important to understand. Text performance is very, very platform dependent. So each platform has its own way of anti-aliasing, its own way of rendering text, its own way of showing styles, its own way of formatting text. So rule of thumb for you guys, rich editable text, okay. Use it if you have like 10 items. No problem. Rich text, 50 items. Label, most of the times you can use a label. If you're using like a single line text, like for example, if you open like a typical travel application like cleartrip.com where you have like those 10 items, you can use a label. But best, if you have like, if you're building an Outlook client, for example, or if you're building like an email client where you will have gazillion emails on your inbox and then you have like those multiple items, each item having multiple text, use a stylable text field. Creating item renderers in MXML is quick and simple, but don't create heavy item renderers. Don't use heavy text components. Cache and queue, we already spoke. Use cache as bitmap carefully. Turn off auto draw background if not needed. By default, the renderers try to draw an opaque background. If you don't need that, turn it off. These are really nice. Any graphic designers here? People from the creative background? Filters and shadows are really nice, sir. I totally love them. They're brilliant, but maybe not a great idea inside a scrolling list. Don't put ternary operators inside your binding expressions. Like, if you're binding, just bind pretty simply, or it is going to be difficult. Yeah, and hang on. Beware of item renderer function. Again, specifically for Flex guys, if you are using item renderer function, it prevents the item renderer from recycling. And use the icon item renderer and label item renderer. So something like this, for example, somebody told me I have like 5 minutes, so I have to show you a demo. Most of the stuff that I want to cover in slides is almost done. Let's see the charts. Rich text. Large throw. You know what a large throw is? Take and flip something. It's called a large throw. When you're moving like this, it's a scroll. You get only 3.5 frames per second when you're scrolling using a rich text. Replace a rich text with label. That thing becomes 7. And your frame rate goes up by how much? Like about 5 FPS on an average. Add a content cache. It becomes 20 and 20. Most of these things are already covered. I'm only showing the statistic backwards. Caches bitmap, 23 and 23. Opaque background plus caches bitmap, 34.5. If you are at the 30 plus frames per second when you are scrolling, that is when you have good performance. Anything that is dropping below 30, I promise you, you can try it out. You can write an application and put a simple frame per second counter. If it is not reading above 30, your list is not performing well. Your scrolling is not performing well. So please make sure that whatever you're writing, eventually it has to, when you're doing something, it has to do it at a rate of at least above 30. Now finally, there are 2 canned components that we give, like an icon item renderer and a label item renderer. For a simple thumbnail and 2 text, you can actually use them. They are super uber optimized. They will actually give you up to 40 frames per second, which is actually quite amazing. Good. So I have time for demo. 3 minutes maybe? 5 minutes here. Can you help me open your the viewer? Yes? It's a very simple on-enter frame code. I'll just show you. I mean, if I get a chance. Otherwise, I'll just find me. I'll actually share that code with you. So basically, whenever an application is running, like if it's JavaScript, there is a on-enter frame that fires. It will work only for things like Canvas. If you take a browser and put an on-enter frame, you'll get like 1 event. But if you're using a Canvas, Canvas has an on-enter frame. Similarly, Flash Player has an on-enter frame. So yeah, hang on. It's too white. Arijit? Yeah, it's coming. Better, no? So can you see it's idling at 24 frames per second? Now, you know where it went to? You won't be able to see it because the refresh is a little slower over there, but it really gets stuck over here. Again, let's try. It's 8 frames per second. 8 frames per second is disgusting. You can't do anything with it. I can see that this, and what happens is like everybody says, no, MXML sucks. Don't do MXML. Let us do ActionScript. Then what happens is people write a very bad ActionScript renderer. ActionScript renderer is so bad that neither do you get the performance of the MXML, nor do you save on time. At least MXML you get bad performance, but it will get done in 10 minutes. The ActionScript, the thing to write will take like 45 minutes to write that thing, and it will still perform as bad as the MXML or worse. So I have a very bad ActionScript renderer. Okay. It's an abysmal 5.7 frames per second. It's ActionScript, there's no MXML. So the thing is, you would commonly go to the internet and see, replace all your MXML with ActionScript, and there you go. No. Most of the times, whatever you write right at the beginning will be a terrible one. But then there's an optimized ActionScript renderer. This code is, can you see the idling itself went up? we saw in the slides 36, right? So we got a peak of 36. We didn't get a 40, but we are generally getting a peak of 33, 32. At least it's significantly more than your. Yeah, so it's ranging between that, while the other ones were between 5.72 to 21. This code is available on my blog. I mean, my blog is currently down for maintenance, but I'll just share you the URL. So this code is available on my blog. And so somebody asked me the question about how to write the frames per second. That code is also being shared. It's actually a simple 4-line function. It's pretty simple. And one disclaimer over here. See, frames per second, as we see over here, is one indicator. So like I mentioned right at the beginning, do not go by that. Don't make this into a smoke test and go by that metric. Okay, I'm getting 35 or I'm getting 34 and my application is performing fine. The perceived performance is extremely critical. So touch and feel is very critical on a touch-based device. So you would know only when you're actually really touching it and understanding how exactly it is working. So unless you do that, it is not really going to help. So, yep.